Hello everyone, myself Sabina Devi, Assistant Professor, Department of Physics. In this video, I am going to explain about the Planck's theory of derivations. Okay, so in previous video, I explained about black body radiation. So the black body is nothing but any object is coated with a black pigment, so it's nearly a black body. So the black body which absorbs all the radiations and it will emit all the radiations. Okay, in some particular temperature bath, it will emit all the radiations. It will not reflect or transmit the radiations into it. Okay, so these are in the previous topic. So the recap. See, before delving into the Planck's groundbreaking work, so let us briefly revisit the concept of the black body radiations. So, what precisely constitutes an ideal black body? So, upon what fundamental parameters does the black body spectrum inherently relay? Okay, so we know that the black body is depending on only the temperature, it's not depending on the material, right? So today our topic is today's topic is the Planck's theory, right? So the core assumptions underpinning a Planck's theory. Okay, so the Planck's innovative theory was the constructed upon the several key assumptions that diverged significantly from the classical understanding. So crucially, these oscillators emit or absorb energy exclusively in discrete quanta, so not continuously. So we know that in quantum theory, it explains the energy was continuous, not a so discrete energy. Okay, so we know that in black body radiations it will emit only the packets of energy, so not a continuous energy. So here the Planck introduced the so Planck has to derive the energy of the black body radiations. Okay, so he has to derive an energy for the black body radiations. So we know that black body. So in black body, the atoms in the black body. So after absorbing the radiations, the behaves like the oscillators, right? Okay, so it has characteristics frequency of oscillation. Okay, so according to the Planck's theory, so he assumed some points. Okay, this all. So the energy is not emitted or absorbed continuously. So the energy only emitted by packets of energy. So it has discrete values. Okay, not continuous values. Okay, so energy is exchanged in discrete packets. That's called quanta. So the energy of the quantum is given by E is equal to h nu. So E is equivalent to h nu. So E is equal to energy. H is nothing but the Planck's constant. Nu is the frequency. So average energy per oscillator. So here the where H is the Planck constant. Okay, so the higher frequency radiation carried in the higher energy. So these are all the assumptions carried by the Planck. So the assumption the atomic oscillator emit or absorb energy only integral multiples of h nu. So the allowed energy levels are E is equal to n h nu. So n is equal to 1, 2 and so on and so on. N is the quantum number. So h is the Planck's constant. Nu is the frequency. The radiation occurs only when an oscillator jumps between the energy levels. Okay. So the explanation of black body radiations, the Planck assumed that atoms in the black body cavity behaves like oscillator. When heated, these oscillator emit energy in the quantized form. So this successfully explained in this theory. So this the observed radiation curve. So no ultraviolet radiations here. So it correct intensity distribution at all the wavelengths. Okay. So the significance of Planck's theory. So why we need Planck's theory? The significance is so it explained the black body radiation completely. So it introduced the concept of quantization of energy. Then it laid to the foundation for the quantum mechanics. Okay, so it lead the developments like photoelectric effect and atomic models. Okay, so these are all the significance of Planck's theory. Okay, so the limitations, so it applicable mainly to the microscopic systems, so could not explain all the atomic phenomena alone. Okay, so the later extended by the Einsteins and Bohr and Schrodinger. So these are the limitations. Only it's mainly applicable to the microscopic systems. So not to macroscopic systems and the minute particles. Okay, so the conclusion is the Planck's quantum theory marked a turning point in physics. So it shows that the energy is quantized, not continuous, and solved the long-standing black body radiations problem. It's led to the birth of the modern physics. So the main black body radiation is the energy is equivalent to h nu. So the remaining parts will be explained in the later videos. Thank you all.